Okay, so in this video, I am going to show you guys how to factor polynomials, and we're just going to focus mostly on the special polynomials. This is not a special polynomial. There is no special way of factoring this. Okay, so we're going to factor this using the greatest common factor method of factoring. So 14 and 7, what's the biggest number that can go into 14 and 7? Well, that's going to be 7. So you can pull a 7 out from both numbers. And then to the 8. And then square. Okay, so square is going to be your greatest common factor. So you're going to be able to pull that out. And then n to the 5th. And then n square. You're going to be able to pull out an n square. 7 square n square is the greatest common factor for those two terms. All right, let's see what's left after we pull out 7 square n square. So 7 goes into 14 is 2. Square goes into to the 8, or to the 8 divided by square is to the 6, because you have to take away the exponent. And then here 5 take away 2 is going to be 3. Okay, and then you can check it if you multiply these two terms. If they're right, you're going to get back the original expression. Okay, and then here 7 goes into 7 one time. Square goes into square is also 1. And then n square goes into n square is also going to be 1. Okay, so that whole thing's just going to come out to 1. If you take 7 square n square times 1, you're just going to get that. So this method is the most common one when you're factoring any kind of polynomials. Okay, first thing you have to do is always look for greatest common factor. Okay, so next we're going to look at difference of squares. Okay, so this is a special polynomial. Okay, there is a method that you can use to factor this kind of polynomials. Okay, so let's take a look at it. Okay, so this is a square. Okay, this is another square. So this is called difference of squares. So when you factor difference of squares, you can easily factor that into a plus b times a minus b. Okay, so these two are the factors of a squared take away b squared. Okay, let's look at an example. Well, is this a perfect square? So is 9x squared a perfect square? How do we know? Well, if you take square root of 9x squared, if it comes out to a perfect number, then you know it's a perfect square. So if I take square root of 9, I'll get 3. If I take square root of x squared, I'll get x. And then if I square it, okay, I'll get 9x squared. And then over here, what's square root of 49? Well, that's going to be 7. What is square root of y squared? Well, that's just going to be y. Now, if I square it, do I get 49y squared? Yes, I do, because 7 squared is 49, and y squared is y squared. So yes, this is a difference of squares. Okay, you can see that the 3x is your a, and then the 7y is your b. So you can easily use those and plug it into the factor form of a squared minus b squared. So what is it? Well, it's going to be a plus b. So that's going to be 3x plus 7y. And then the other one is a minus b. So that's going to be 3x take away 7y. Okay, so this is the factor form of 9x squared take away 49y squared. Let's take a look at another one here. Okay, difference of squares. So 10w to the fifth, take away 10w. So as of right now, 10w to the fifth is not a perfect square. Okay, because when you take square root of 10, it's not going to come out to a nice number. When you begin your factoring, okay, what you need to do is always look for greatest common factor. So let's see if I can pull anything out from these two terms. Looks like 10, 10. So 10 is your greatest common factor. So you can pull a 10 out. W to the fifth, W, you can pull out a W. Okay, so if I pull out 10W here, I'm going to have 1W to the fourth minus 10W goes into 10W one time. 10W is going to be the greatest common factor. Let's see if this is difference of square. So if I take square root of W to the fourth, I'll get W squared. And then when I square it, I'll get W to the fourth. And then when I take square root of 1, I'll get 1. And then when I square 1, I'll get 1. So this is good. So this right here is difference of squares. Then I can say that the W squared is the A, and then the 1 is the B. So now that I have my A and my B, I can just put those into the factor form. So 10W, and then it's going to be A plus B, so that's going to be W squared plus 1. And then it's going to be A minus B, so that's W squared minus 1. So these are the three factors. Looks like we can still factor this because these are perfect square. Okay, so 10W. So you can factor this into W plus 1 and then W minus 1. Okay, so next we're going to get into sum of cubes. Okay, so sum of cubes is a special polynomial. So we have a formula that we can use to come up with the factors. So let's take a look at it. Okay, so this is a cube. So a cube, sum is add, and then another cube. So you can easily factor this into a plus b. Okay, a plus b is one of the factors. And then the other factor is a squared minus ab plus b squared. Okay, so let's take a look at an example. Okay, so is this a cube? When you take cube root of cube, you get And then if you cube it, you get cube. And then over here, when you take cube root of 216, it's going to be 6 because 6 times 6 is 36. Times 6 again is 216. And then cube root of n to the third is just going to be n. And then if you cube it, you get 216 n cubed. Okay, so yes, these are cubes, and it's the sum of cubes. Okay, so now that you have your A and you have your B, you can just plug those into the given formula. So the first one is going to be A plus B. So that's going to be plus 6n. And then A squared, well that's squared, minus A times B. So A times B. So it's going to be times 6n. Well, that's going to be 6n. And then plus b squared. So 6n squared is going to be 36n squared. Okay, so these are the two factors of the given polynomial. Okay, so let's take a look at another one. Looking at this, this is not a perfect cube at the moment. This is also not a perfect cube at the moment. Let's see if there is a greatest common factor between these two terms that we can pull it out. So between 24 and 375, okay, we can pull a 3 out. C to the 4 and C, we can pull a C out. And then D to the 4th, we can pull a D out. Okay, so 3CD is your greatest common factor. Let's find out what is left inside the parenthesis. So 3 goes into 24 8 times. 4 take away 1 is going to be 3. What D goes into D is 1. And then 3 goes into 375 is going to be 125. And then C goes into C is 1. And then D goes into D to the 4th is D to the 3rd. Okay, so this is what's left after we took out the greatest common factor. Okay, let's see if we can rewrite this as the sum of cubes. Well, cube root of 8 is 2. Cube root of C to the 3rd is C. And then if we were to cube it, we get 8C cubed. And then over here, cube root of 125 is 5. And then cube root of D to the 3rd is D. And then if we were to cube it, we get 125D cubed. So yes, we can keep on going knowing that now this is going to be your A. This is your B. So we can just plug those in. So I'm going to bring down the 3CD because that's the greatest common factor. And then it's going to be A plus B. So that's 2C plus 5D. And then it's going to be A squared. So 2C squared is going to be 4C squared minus A times B. So that's going to be 10CD. And then plus 5D squared. So 5D squared is going to be 25D squared. So now we're going to get into difference of cubes. Very similar to sum of cubes. Okay, the only difference is that instead of a plus in between, you have a minus in between the two cubes. Okay, so let's take a look at the formula. So here you have when you have A cubed minus B cubed, you can factor that into A minus B, and then A squared plus AB plus B squared. Okay, so let's take a look at the first example. Let's see if we do have difference of cubes. Okay, so if I take cube root of 216, I'll get 6. Cube root of k to the 3rd is just going to be k. And then if I cube it, I'll get it back. Good. And then here, cube root of 125 is 5 because 5 times 5 is 25 times another 5 is 125. And that's what happened when you cube it. Look how easy this is now because you have your A and then you have your B. Okay, you're just going to plug those in. So the first one is going to be A minus B. So that's going to be 6k take away 5. And then the second one is A squared. So 6k squared is going to be 36k squared. Plus A times B. So that's going to be 30k. Plus B squared. So 5 squared is 25. That's it. You're done. Okay, so let's take a look at another one here. Working with difference of cubes. This is the polynomial. So as of right now, it doesn't look like you have a cube here because when you take cube root of 2, it's going to come out to a decimal number. Same thing over here. So let's see if we can pull anything out. Greatest common factor. Yeah, it looks like you can pull a 2 out. Left with x cubed. Take away 27y cubed. Let's see if these are perfect cubes. So cube root of x is just going to be x. And then if you cube it, you get x cubed. Cube root of 27 is 3, and then cube root of y to the third is just going to be y. And then when you cube it, you get 27y cubed. All right, so looks good. So this is the A, this is the B. Okay, so we're just going to plug those in to the formula. We're going to bring down the 2 because that's one of the factors, the greatest common factor. And then you have A minus B, so that's going to be x take away 3y. And then A squared, well, that's x squared, plus AB, 3xy, and then plus 3y squared is going to be 9y squared. All right, so here we have 9y squared. So we're done. Okay, so now we're going to get into trinomials. Okay, so how do we factor a polynomial with 3 terms? Okay, you got w cubed plus w squared take away 20w. Okay, if you look at all 3 terms, they all have at least a w. So therefore, you can pull out a w, and w is going to be your greatest common factor. Okay, so we're going to pull out a w. So then we have w squared plus w take away 20. Okay, so when you pull out w from here, w goes into w cubed is w squared. W goes into w squared is w. And then w goes into 20w is 20. Now you have to factor this trinomial. And you can factor this using the AC method. So for the AC method, so a times c, a is 1. 1 times negative 20 is going to be negative 20. And then the value of b is 1. So now we have to come up with factors of negative 20 that when you add them up, it comes out to 1. Okay, how about we use 4 and 5, but then we need the 4 to be a negative number that when you add them up comes out to 1. So these are the 2 numbers we're looking for. So now we're going to write this in factor form. Okay, so we bring down the w. So this one's going to be w take away 4 because of the negative 4. And then this is w plus 5 because of the positive 5. Okay, so these are the factors of the original expression. Okay, let's take a look at another trinomial. Okay, so we're going to factor this trinomial. We have to see if there is a greatest common factor other than 1 that we can pull out. 2 can go into all of these numbers. And then you can also pull out an a because they all have at least an a. So your greatest common factor is going to be 2a. Okay, that's your GCF, greatest common factor. And then you're left with a squared plus 2 goes into 38 19 times. So it'll be 19a. And then plus 2 goes into 68 is 34 times. So this is what you have left after you pull out 2a. Factor the inside using the AC method. AC. So A is 1, C is 34, so 1 times 34 is 34. And then your B is 19. Okay, so we have to come up with factors of 34 that when you add them up, it comes out to 19. So 17 and 2. Okay, so these are the 2 numbers. So we bring down the 2a. And then we're going to write out the factors of this. So it's going to be a plus 17 times a plus 2. Okay, so these are the factors of the original expression. So now we're going to get into factoring polynomials with 4 terms. So this expression right here, this is a polynomial, and as you can see, it has 4 terms. So we're going to factor this using the grouping method. Okay, so to use the grouping method, we're going to break this up into 2 groups. Okay, so this is the first group, and then this is the other group. And then from each group, you're going to factor the greatest common factor. Okay, so the greatest common factor for this is going to be k squared. So you pull out a k squared. So and then when you're left with k plus 5. And then here you have to pull out a negative 1. And then you have k plus 5. Okay, and then you're going to factor out the common binomial. So what's the common binomial here? It's going to be k plus 5. See, that's your common binomial. So you're going to pull that out, k plus 5. Okay, so if you pull this out, you're left with k squared. And then if you pull this out, you're left with negative 1. This is a difference of squares. So you have to continue to factor that into k plus 1 times k minus 1. So this is it. There's nothing else you can do to this. So we're done. Okay, so let's take a look at another one with 4 terms. Okay, so this is a polynomial, 4 terms. Okay, we're going to factor this again by grouping. So we're going to break this up into 2 groups. So here's your first group. This is your second group. Okay, so now we're going to pull out for this group right here. We're going to take out the greatest common factor. Looks like we can pull a 2 out and then x to the 4. And then you have x left over minus 9. And then here you're going to be able to pull a 7 out. And then you're left with x take away 9. Okay, and then you're going to factor the common binomial. So the common binomial is the x minus 9. So you're going to pull that out, x minus 9. You're left with 2x to the 4th. And then you pull this out, you're left with a positive 7. Okay, so those are the factors of the original polynomial.